Ladies, this is Miss Loden, and this is section 2.5, goal 2. We did not finish our second example in class the other day, so I'm going to do that for you now. Find a fourth degree polynomial function with real coefficients that has 4 and 2i as zeros, and such that f of -1 equals -50. Let's first take the zeros that we do have and write them in factored form. Remember, if f equals 4 is a 0, then x minus 4 is a factor. If x equals 2i is a 0, then x minus 2i is a factor. Recall that complex numbers come in conjugate pairs, so if positive 2i is a 0, then negative 2i is a 0. And the factor for negative 2i is x plus 2i. Okay, now that we have the factored form, make sure we don't forget that we also must have a leading coefficient. This problem did not give us the value of the leading coefficient. So I'm going to say that the leading coefficient is the variable a, and we will use f of -1 equals -50 to solve for that leading coefficient. So let's do that now. In the place of f of x, I will replace f of x with -50, which is my y value, and that's equal to a times, in the place of x, we'll replace that with -1. So -1 minus 4 times -1 minus 2i times -1 plus 2i. Let's go back and do the algebra here. -50 is equal to a. -1 minus 4 is -5. Remember, when we're multiplying conjugates, we only have to multiply the first and the last. -1 times -1 is +1. -2i times +2i is -4i squared, which is +4. Okay, so that means that we have -50 is equal to a times -5 times +5. So -50 is equal to a times -25. So a is equal to 2. All right, so at this time, let's go back and replace a with the leading coefficient of 2. Now remember, it says find a fourth degree polynomial, and you may think, in fact, I realized that I left some information out here. If it's fourth degree, we should have 1, 2, 3, 4 factors, and we don't have a fourth factor. So I should have mentioned that 4 has a multiplicity of 2, and that was my fault for not mentioning that, which that means that's going to change all of this information. So I'm going to cheat a little bit, and rather than change the information, I'm going to say find a third degree polynomial. So you're not allowed to do that on a test or a quiz, but I am. So that's what we're going to do. So that takes care of all of this without us having to go back and change all of our work. All right, so let's multiply out and get that polynomial. F of x. Oh, actually, I told you that when you get to this point, you're allowed to use the expand function on your calculator, so I want to show you how to do that now. Okay, from your home screen, open a new calculator, and under menu, you'll go to Algebra, Expand. And it opens the expand function. Notice there's a set of parentheses for you, and that's where you will enter your function that you'd like to expand. So 2 times x minus 4 times x minus 2i times x plus 2i. And when we press enter, let's look at this carefully. We have 2 times 2x cubed minus 8x squared minus 8i squared times x plus 32i squared. So notice while it did square the I for you, it didn't go ahead and calculate that. Let's see if we press enter again or Control Enter if it'll do that for us. It does not. So you will have to go back if you use expand and square the i's and then combine your like terms. Let's go back over here, and I'm just going to do the work here because I don't like that it didn't do that for us. Okay, so we have 2 times x minus 4. And remember, when we FOIL conjugates, that gives us first times first, so x squared. And then negative 2i times positive 2i is plus 4. And now we will FOIL again. X times x squared is x cubed. That's the first. And then the inside is minus 4x squared. The outside is plus 4x. And then the last is minus 16. Now, and only now, do we distribute the 2. So remember to follow order of operations, do the parentheses first, and then once you have a polynomial, then you could distribute the 2. So that would give us f of x equals 2 x cubed minus 8 x squared plus 8x minus 32. All right, ladies, thank you so much for tuning in. I'll see you next time.